We said in the last video how to calculate the volume of regular objects like spheres, cylinders, cubes, or cones, and how to use the volume of these objects for finding density. But there are a lot of objects which don't have well-shaped design. For example, consider a piece of a rock. If you want to measure its volume, you can't do it with cookies or ruler. So we need to use another method. For measuring the volume of this object, we use a graduated cylinder and insert the rock in the cylinder. I mean a cylinder that there is some water in it. So when you insert the rock inside the graduated cylinder of water, the water doesn't have any place to escape. It just rises. So the amount of water which rises, I mean its size or its volume, is equal to the volume of the irregular object which was inserted in the graduated cylinder. So the volume of this part of the water inside the graduated cylinder which has risen is equal to the volume of this rock. Pay attention that their volume are equal, not their mass. One of them is water and the other one is rock. It could be, for example, metal, so their mass are not equal, just their volume are equal. So we can write an equation for that. The volume of the displaced water, we say water, but you should consider that it can be any kind of fluid. It can be, for example, alcohol or anything else. The volume of displaced water is equal to the volume of the irregular object that we are going to find its density or volume. So the volume of irregular object. So if we, for example, insert irregular object like a rock inside a graduated cylinder like that, and for example the amount of water has been raised 3 centimeters, then since the graduated cylinder has a well-shaped design and it's a cylinder, we can find its volume easily. And we know that the volume of the cylinder is equal to area of the cylinder base, which is pi r2 to the 2 times the height of the cylinder. This is the volume of the displaced water, which is equal to the volume of the irregular object like a rock. So let's go through some questions. Okay, let me bring you the question. A piece of metal with mass of 500 grams is inserted into a graduated cylinder of water, and the volume of water increases to 150 centimeters cubed. What is the density of this object in SI unit? Oh, let me correct this part. 3 should be on top of centimeter. Okay. So the mass of the metal is 500 grams. And its volume is 250 centimeters cubed. It means that the mass of metallic object is equal to the displaced water. Since the volume of water has increased to 250 centimeters cubed, it means that the volume of that object is 250 centimeters cubed. So this is the volume of the metallic object. So is the density equation, and density is equal to 500 grams over 250 centimeters cubed, which is equal to 2 grams per centimeter cubed. But since the question wants us to find the density of this object in SI unit, we have to convert the unit of density to SI unit. And we know that the unit of density in SI unit is kilogram per meter cubed. And we know that for converting grams per centimeter cubed to kilograms per meter cubed, you just need to multiply the number by 1000. Or if you don't have that in mind, you can do it by unit conversion. Or you can easily just write rho or density is equal to 2 times, and instead of grams, we can write 10 to the minus 3 kilograms, and instead of centimeter, we can write 10 to the minus 2 meters raised to the power of 3. So it's equal to 2 times 10 to the minus 3 over 10 to the minus 6 kilograms per meter cubed, which is equal to 2 times 10 to the minus 3 times 10 to the 6, because minus 6 comes to the top and the sign of this exponent changes, which is equal to 2 times 10 to the 3 kilograms per meter cubed. So the density of this metallic object in SI unit was 2000 kilograms per meter cubed. Now let's go to the next question. A piece of metal with the mass of 90 grams is inserted into a graduated cylinder of water, and water level increases 1.2 centimeters. Okay, let us draw a picture of cylinder, and this is the piece of metal, and the question says that the water level rises 1.2 centimeters. If the area of the cylinder base is 10 centimeters squared, so the question has given us the area of the cylinder base, so it means the area of this part, we have it and we show it by A, is equal to 10 centimeters squared. Okay, calculate the density of metal in grams per cubic centimeter. So for knowing the density of the metal, we should know the volume of this object. But we know that the volume of this metallic object is equal to the displaced water. How much water is displaced? Okay, we can calculate the displaced water in the graduated cylinder. If I draw this part with blue, this is the displaced water. The volume of this part is equal to area times H, which is equal to 10 centimeters squared times 1.2 centimeters, which is equal to 12 centimeters cubed. Okay, this is the volume of the displaced water, or the volume of the metallic object inside the graduated cylinder. Both of them are equal. So since we have the volume of the metallic object, and we know its mass, which is 90 grams, we can calculate density easily by using the density equations. By using the density equation, right, rho is equal to mass over volume, which is equal to 90 grams over 12 centimeters cubed, which is equal to 7.5 grams per centimeter cubed. Okay, next question. A piece of metal with density of 2.7 grams per centimeter cubed is inserted into a cylinder filled of alcohol, and 160 grams of alcohol overflows. What is the mass of metal in grams? The question is asking us to find the mass of the metal in grams. Okay, this is a beautiful question. Let us draw the cylinder at first. Okay. So consider that this cylinder is full of alcohol and there's nothing inside it. So now we insert a piece of metal inside it. As you see, the alcohol overflows and some amounts of alcohol pours out. Okay, this is alcohol. The question is asking us to find the mass of the object. For finding the mass of the object, we should find the volume of the metal, because we have its density, and if we find its volume, we can find its mass. Okay, how much is the volume of this object? We already explained that the volume of displaced water is equal to the volume of the object. Okay, how much water is out of the cylinder? Question states that 160 grams of alcohol overflows. You should pay attention that the volume of the alcohol which is out of the cylinder is equal to the volume of the object, not the mass of the alcohol that is out. So, since the question has given us the mass of the alcohol which is out, which is 160 grams, we should use density equation and find the volume of the alcohol out, and which is equal to the volume of the object, which is inside a graduated cylinder. So it seems that we should use the density equation twice in this question. First, for the alcohol out, rho is equal to m over v, and we know that v is equal to m over rho, density. We use this equation for alcohol to find the volume of the alcohol which is out. So if we find the volume of the displaced alcohol, which in this case alcohol overflowed and is out of the graduated cylinder, we can find the volume of the object, and if we find the volume of this object which is in the graduated cylinder, we can use the density equation and find its mass. So we write the density equation for the alcohol at first. Volume is equal to mass of the alcohol, which the equation is given you, 160 grams, over the density of the alcohol, which is 0.8 grams per centimeter cubed. And if you divide these two terms, it's equal to 200 centimeters cubed. Okay, now as you see, this is the volume of the displaced alcohol, the volume of the alcohol which is out of the graduated cylinder. And since we know that the volume of the displaced alcohol or the displaced fluid is equal to the volume of the object inside the graduated cylinder, this is equal to the volume of the object. It means this one. Okay, so we have its volume and we have its density. We use again the density equation and write m is equal to density times volume, which is equal to 2.7 grams per centimeter cubed times 200 centimeters cubed. And if you multiply these two terms, as you see, centimeters cubed cancel. And the final answer is 540 grams. So the mass of the object inside the graduated cylinder is 540 grams. Okay, let's pay attention to the next part, which is about density of mixed fluids. Imagine that, for example, we have three fluids A, B, C, and we have mixed them together. And we want to find the density of mixed fluids. And we know that the total density is equal to total mass over total volume. So in this equation, since we have three fluids, the mass of three fluids is the sum of individual masses. We have three fluids A and B and C, so the total mass is equal to sum of individual masses, m of A plus m of B plus m of C. And the total volume is equal to sum of individual volumes, V of A plus V of B plus V of C. So the density of mixed fluid is equal to total mass over total V, which is equal to m of A plus m of B plus m of C over V of A plus V of B plus V of C. This is a general equation that you can use it for different fluids. For example, if you have just fluid A and B, you erase this part, and the mixed density is this. But since we have three types of fluids, we write all of them. You don't need to memorize this formula, it was proven easily. So when in a question the masses of different fluids and the volumes of different fluids are given to you, you can find the density of mixed fluids easily. But sometimes in some questions, masses of different fluids are not given, and the only thing is given to you is the volume and the density of different fluids. So when the density is given to you, you can write instead of m of A, rho A times VA, and instead of m of B, rho of B times V of B, and instead of m of C, you can write rho of C times V of C. So if you substitute these three terms in the general formula, you can write rho of A times V of A plus rho of B times V of B plus rho of C times V of C over V of A plus V of B plus V of C. Let's solve a question related to this part. What volume of a fluid in cubic centimeters and density of 1 grams per centimeter cube should we mix with 500 centimeters of water so that the mixed density would become 1.1 grams per centimeter cubed. Density of water is 1 gram per centimeter cubed. So as you see, the equation is talking about the mixed density, and we should use the mixed density equation. We first make two brackets and write a primary condition of two fluids. First one is water, and the volume of the water is 500 centimeters cubed, and the density of water is given to, its density is 1 gram per centimeter cubed. And for the unknown fluid, its density is 1.2 grams per centimeter cubed, and its volume is unknown. But the mixed density is given. The mixed density is 1.1 grams per centimeter cubed. So the volume of the fluid is unknown. We need to find the volume of the fluid. But let us call for water V of 1 and rho of 1, and for the fluid V of 2 and rho of 2. We use the mixed density equation, and we write rho of m is equal to m of 1 plus m of 2 over V of 1 plus V of 2. Okay, we don't have masses, so instead of mass, we write rho times V. So rho of 1 times V of 1 plus rho of 2 times V of 2 over V of 1 plus V of 2. I wrote it again so that tell you not to memorize this formula and prove it for every question. Okay, the mixed density is given. The mixed density is 1.1 grams per centimeter cubed, which is equal to rho of 1 is 1, V of 1 is 500 centimeters cubed, plus rho of 2 is 1.2, V of 2 is unknown, and V of 1 is again 500 centimeters cubed, and V of 2 is unknown. So you solve this equation for V of 2 and you can find the answer easily. Just multiply both sides of the equation by denominator, and the answer is 550 plus 1.1 V of 2 is equal to 500 plus 1.2 times V of 2. So 550 minus 500 is equal to 50. It's equal to 1.2 minus 1.1 is equal to 0.1 V of 2. And V of 2 is 500 centimeters cubed. So the unknown fluid should be 500 centimeters cubed, so that we mix it with water of volume 500 centimeters cubed, so that the mixed density would become 1.1 grams per centimeter cubed. Okay, next question. A mix of two kinds of fluids with densities of rho of 1 and rho of 2 has been made. If 1/3 of its volume is of density rho of 1 and 2/3 of its volume is of rho of 2, what is the mixed density in terms of rho of 1 and rho of 2? So for answering this question, we make two brackets and write the primary conditions of two fluids. For first fluid, its density is rho of 1, and the second fluid, its density is rho of 2. And the question is telling that 1/3 of its volume is of density rho of 1. So let's try a cylinder. So 1/3 of this cylinder, 1/3 of this cylinder is filled with fluid 1, and the rest of this volume, it means 2/3 of that is filled with density of rho of 2, with fluid 2. So 1/3 of that is from fluid 1, and 2/3 of that is from fluid 2. Okay, the question is telling us that 1/3 of the volume of the cylinder is from fluid 1, and 2/3 of that is from fluid 2. So if we consider the total volume of this cylinder, this graduated cylinder V, okay, let me consider the total volume of the cylinder V. So we can write 1/3 of V and 2/3 of V, and V is the total volume of the cylinder. So in the bracket again we can continue and write V of 1 is equal to 1/3 of V And V of 2, the volume of the second fluid, is equal to 2/3 of the total volume. And the total volume of the cylinder is V. So since we have densities of two fluids and their volumes, we can easily calculate the mixed density. And we know that the mixed density equation is written as M1 plus M2 over V of 1 plus V of 2. So here, instead of M of 1, we can write rho of 1 times V of 1. And instead of M of 2, we can write rho of 2 times V of 2. So we substitute in the numerator. Let me erase this part. So we can write rho of M is equal to rho of 1 times V of 1 plus rho of 2 times V of 2 over V of 1 plus V of 2. But what is the sum of V of 1 plus V of 2? We know that V of 1 is the volume of fluid 1 and V of 2 is the volume of fluid 2. So let me write it. So if we sum these two terms, V of 1 plus V of 2, it would be the total volume of the cylinder. So V of 1 plus V of 2, you can write it 1/3 of the total V plus 2/3 of the total V, which is equal to V, the volume of the cylinder. So we can substitute instead of this part V, and we can write the mixed density is equal to rho of 1 times 1/3 of V. Let me erase this part. Rho of 1 times 1/3 of the total volume plus rho of 2 times 2/3 of the total volume over the total volume, V, the volume of the cylinder. So as you see, just we have the volume of the cylinder at the top and bottom. So the volume of the cylinder cancel each other from top and bottom. So what is left is 1/3 of rho of 1 plus 2/3 of rho of 2. Or the mixed density we can write as 1/3 of rho of 1 plus 2/3 of rho of 2, which is equal to rho of 1 plus 2 times rho of 2 over 3. So we could write the mixed density in terms of individual densities. Okay, let's pay attention to a more difficult question. There is a mix of two substances A and B with densities of 4 grams per centimeter cubed and 18 grams per centimeter cubed. If the mass of B is 3 times the mass of A, what is the mixed density in grams per cubic centimeter? So for answering this question, we first make two brackets again for fluid A and fluid B. The density of fluid A is 4 grams per centimeter cubed, and the density of fluid B, I should write it here, and the density of fluid B is equal to 18 grams per centimeter cubed. So the mass of B is 3 times the mass of A, and the question is asking us to find mixed density. What is the mixed density? So we should use the mixed density equation again. We know that the mixed density is equal to M of A plus M of B over V of A plus V of B. But pay attention that in this equation we don't have volumes. We don't have the volume of A and volume of B. What should we do? We can write volume of A in terms of density and mass of fluid A. So if you write density equation, rho of A is equal to M of A over V of A, we can find V of A, which is equal to M of A over rho of A. We can do the same for V of B too. Rho of B is equal to M of B over V of B. So V of B is equal to M of B over rho of B. Now if you substitute these two terms in density equation, we can write M of A plus M of B over M of A over rho of A plus m of b over rho of b. Okay, let me erase this part so that we have more space to write. Now we have m of a and m of b, and rho of a and rho of b. So we can find the mixed density easily. The mixed density is equal to m of a plus m of b, which instead of m of b we write 3 times m of a. So m of a plus 3 times m of a. This is m of b. So instead of m of b we wrote 3 times m of a over m of a over density, which is 4, plus 3 times m of a. Instead of m of e again we wrote 3 times m of a. Let me correct this part. M of a over 4. 4 is density of fluid A. Okay, so if you solve this equation and MA's cancel from top and bottom, 1 plus 3 is 4, and at the bottom 1/4 plus 3/18. So if you solve it or use a calculator, we just write the final answer. The final answer is 9.6 grams per centimeter cubed. So the final answer is 9.6 grams per centimeter cubed. In the next part, we are going to compare the densities of two objects. Imagine that, for example, density of two objects are given. Density of, for example, the first object is rho of 1, and the density of the second object is rho of 2. And you are asked to compare the densities of two objects. So, for finding the ratio of two objects, we write rho of 1 over rho of 2 is equal to m of 1 over v of 1 divided by m of 2 over v of 2, which is equal to m of 1 over m of 2 times v of 2 over v of 1. Okay, this is the ratio of densities, but you may be asked to find the ratio of masses. We know that mass of 1 is rho of 1 times v of 1, and mass of the second object is rho of 2 times v of 2. So the ratio of masses is rho of 1 times v of 1 over rho of 2 times v of 2. Again, I say that you don't need to memorize these equations, you better prove it every time. Let's go through a question. Volume of substance A is twice the volume of substance B, and its mass is 3 times the mass of B. What is the ratio of density of A1 to substance B? The question is asking us to find the ratio of rho of 1, rho of A to rho of B. So, we know that V of A is twice the V of B. And M of A, it means the mass of substance A is equal to 3 times the mass of B. So we have these two terms, and the question is asking us to find the ratio of densities. It means rho of A over rho of B. Okay, excuse me. Ratio of densities, rho of A over rho of B is equal to m of A over V of A divided by m of V over V of V, which is equal to m of A over m of B times V of B over V of A. We suggest you prove that every time. So it's equal to, instead of m of A, we write 3 times m of B. And we write m of v itself, times we write v of v itself, and instead of v of a we write 2 times v of b. Now you can find the answer easily. M of b's cancel and v of b's cancel, and what is left is 3 over 2, which is 1.5. Okay, next question. Density of fluid A is 4/5 of density of fluid B. if the volume of 8 kilograms of A is 10 liters, what is the volume of 5 kilograms of B in liters? Okay, for answering this question, we make two brackets again, one for A, one for B. Okay, rho of A is 4/5 of rho of B. If the volume of 8 kilograms of A is 10 liters, so M of A is 8 kilograms. We have its mass too. And V of A, we have its volume. V of A is 10 liters. Now we make another bracket for fluid B. What is the volume of 5 kilograms of B? So M of B is 5 kilograms. M of B is equal to 5 kilograms. The question is asking us the volume of B. We need to find volume of B. Well, in this question we can convert the units of volume from liters to meters cubed. But we don't need to do it because the question is given us the primary conditions in liters and it wants the answer, the volume of B in liters too. So we don't need to convert. We don't need to convert from liters to meters cubed. Okay, let's answer the question. From these two terms, M of A and V of A, we can find the density of A. So the density of A is equal to M of A over V of A, which is equal to 8 kilograms over 10 liters. So density of A is 0.8 kilograms per liter. You see that we could find the density of A. We should find the density of B to find its volume. So we use this equation. This equation is telling us that rho of A is 4/5 of rho of B. We use this equation and convert it. And we can write from this equation that rho of B is equal to 5/4 of rho of A. So instead of rho of A, we can write 0.8 kilograms per liter. So rho of B is equal to 5/4 of 0.8 kilograms per liter, which is equal to 1 kilogram per liter. So we could find the density of fluid B. Its density is 1 kilogram per liter. So we use this density and use the density equation for fluid B, and we can find the volume of B here. So if you use the density equation, rho of B is equal to M of B over V of B. If you solve it for V of B, we can write V of B is equal to M of B over rho of B. So we have M of B is 5 kilograms and rho of B is 1 kilogram per liter. So the final answer is 5 liters. So the volume of fluid B is 5 liters. Okay, pay attention to the last problem. The mass of two metallic spheres A and B are equal if the radius of sphere A is 3 centimeters and the radius of sphere B is 6 centimeters compared to density of A relative to density of B. So if we first write the primary conditions, it is telling that M of A is equal to M of B. And radius of A, which we write it as R of A, is equal to 3 centimeters. And radius of B is equal to 6 centimeters. What is the ratio of densities? Rho of A over rho of B. So for comparison of two densities, we can write rho of A over rho of B is equal to M of A over V of A divided by M of V over V of B, which is equal to M of A over M of B times V of B over V of A. So the masses are equal. So the masses cancel. M of A is equal to M of B. So they cancel. what is left is V of B over V of A. So rho of A over rho of B is equal to V of V over V of A. And we know the volume of a sphere is 4/3 of pi times r to the 3. And write the same for the sphere A2. So as you see, 4/3 of pi cancel again from top and bottom. And what is left is r of B to the 3 divided by r of A to the 3. And we can write it as r of B over r of A to the 3. So rho of A over rho of B is equal to, the radius of B is 6 centimeters and the radius of A is 3 centimeters to the 3. 6 over 3 is 2, 2 to the 3 is 8. So the ratio of densities rho of A over rho of B is 8, or rho of A is 8 times rho of B. Okay, this was the end of density problems. Have a great day.